Good day, everyone. Today we will present our project titled Computational Neuroscience for Naturalistic Neurophenomena. This project is conducted by Changlan Chen and Yuanzheng Han under the supervision of Professor Subing Lim and Professor Chao Yutan. Let's start by discussing the problem we are addressing. Cognitive limitations, particularly in working memory, are significant challenges in understanding how the brain functions and in developing AI systems that can mimic human cognition. Traditional models often focus on the capacity limitations of working memory, but these models tend to overlook the important constraints imposed by sensory processing and neural architecture. In our project, we aim to investigate these limitations by simulating cognitive processes using convolutional neural networks and recurrent neural networks. Our focus is on real-time multi-stimuli environments, which will provide new insights into working memory and help inform the development of AI systems. Now let's look at the relevant research in this area. First, Carandini and Hager introduced the concept of normalization as a fundamental neural computation across sensory modalities. It helps maintain contrast sensitivity and prevents neural saturation, improving sensory input processing. However, this work is mainly focused on sensory processing and does not directly address working memory limitations. Similarly, Bayesian models in perception, as discussed by Gershik and Wei and Stalker, highlight how environmental statistics influence perception and bias, while they provide a framework for understanding perception anomalies. They don't fully explain the constraints on working memory in dynamic, multi-stimulus environments. Next, artificial neural networks have applied to neuroscience to simulate complex neural computations. For example, Ma et al. Proposed probabilistic population codes for Bayesian inference in neural populations, and Yang and Wang introduced AANs to model a wide array of brain functions. However, these models often lack application in naturalistic real-time processing involving working memory. Additionally, Taylor and Bay, Benjamin et al., and Xie et al. Explored constraints in working memory, showing that neural constraints like neural coding and sensory cognitive models explain working memory limitations. However, these models may not capture the full complexity of processing multiple stimuli in real time. With this background, our project seeks to address these gaps. We combine CNNs and RNNs to simulate brain functions in real time, multi-stimuli environments, moving beyond static capacity models of working memory. Our unique contribution lies in focusing on naturalistic settings, where complex stimuli must be processed dynamically, close to mimicking how the brain works. By addressing the cognitive limitations observed in human working memory, our objective is to develop AI systems that better replicate human-like cognitive ability, particularly in multitasking and real-time processing. Finally, let's discuss the expected contributions of our project. In computational neuroscience, we aim to provide new insights into how natural constraints influence working memory capacity by offering a unified modeling approach. Our project integrates sensory processing with working memory. In terms of AI development, our research will help inform the creation of AI models that mimic human multitasking abilities and enhance real-time processing, especially in environments requiring simultaneous handling of multiple stimuli. Thank you for your attention. We're happy to take any questions you might have.